Hi students. Okay, let's look at plotting linear graphs. Now there are three methods to do this. Number one, first of all, is just using the table. Number two is using the form y equals mx plus c, which you've seen before. And also the third one, x and y intercept method, we'll do in a separate video. So today, just want to look at the first two. So first of all, using the table. Let's take an example. Let's look at, for example, y equals 3x plus 2. And they're asking us to graph this linear equation. So what I have to do first of all is simply just choose some values for x. And the easiest ones are 1, 2, and 3. Let x be equal to 1, 2, and 3. You only need 3 points, but you can do a few more if you want, just to check. So let's substitute. If x is 1, 3 times 1 is 3, plus 2 is 5. So there's my first point, 1, 5. If x is 2, 3 times 2 is 6, plus 2 is 8. There's my second point, 2, 8. And if x is 3, 3 times 3 is 9, plus 2 is 11. So there's my third point. You can do more points if you like, but you really only need 3. And then we go ahead and plot those points. So first of all, the point 1, 5. Here's the x-axis. 1, 2, 3, 4, 5. So my first point there is the point 1, 5. The second point is the point 2, 8. There's 2, 1, 2, 3, 4, 5, 6, 7, 8. There's the second point. We always use a third point just as a check. So the point 3, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is the third point there. And these are 3 points. All you have to do now is just draw your line through those points, and that's the graph of y equals 3x plus 2. Alright, and that's called the table method. So it's just picking points, finding the corresponding y values, and then graphing them. Now, the second method was y equals mx plus c. Remembering m is the gradient and c is the y-intercept. So, let's look at these examples here. Y equals 3x plus 2, and we're going to graph all of these simply just using it. Now remember, m is the gradient, c is the y-intercept. So looking at these, that's the gradient, there's the y-intercept. There's the gradient, that's the y-intercept. Gradient, y-intercept. Gradient, y-intercept. This is a really quick method of doing it. So let's look at the first one. The gradient is 3, and I'm going to change that to a fraction, 3 over 1, and the y-intercept's 2. So graphing that, the y-intercept was 2. So this is where it intercepts the y-axis. And the gradient was 3, or 3 over 1. So that means I go up 3, across 1. Now this method you only get 2 points. So you've got to be accurate with it. And that's the graph of y equals 3x plus 2. Let's look at the second one. Y equals 3x minus 4. The y-intercept this time was minus 4. So I find minus 4 on the graph. 1, 2, 3, 4. It's down here. And the gradient is 3 over 1. So we go up 3 from that point and across 1. There's my graph. And because they've got the same gradient, remember, they'll be parallel. Let's look at the third one. Y equals negative 2x plus 2. So the y-intercept is 2, which is here again, but the gradient this time is negative 2 under 1. Remembering with a negative gradient, you go down 2 and across 1. There's my second point. There's the graph of y equals negative 2x plus 2. The third one, y equals 3/4 x minus 1. So the y-intercept is minus 1, which is here. The gradient this time is 3 on 4. So that means from that point we go up 3 and across 4. There's my second point. Draw the graph. It's getting a bit messy here with all these graphs, but it's easier just doing it on one page. The last one is y equals 5x. Now in this case, there is no y-intercept, or the y-intercept is actually 0. And the gradient is 5, which is 5 on 1. So from here I go up 5, 2, 3, 4, 5 and across 1. And then you draw your line through it. Alright. Now notice the y equals mx plus c method means that the form of the equation has to be in y equals mx plus c. Okay, have a go at some of those exercises and we'll do the x and y intercept method on the next video. Good luck.